All right, welcome back. This is an ALEKS topic that's called solving for a reactant using a chemical equation. This is a really great ALEKS topic. I think it tests a lot of different things, and definitely you should be able to do this, right? You should be able to master this topic. If you can't, I would say that's definitely a problem for you moving forward in chemistry. This is sort of a very fundamental type question that you really do need to understand and do if you're going to be successful in chemistry. So very important. All right, let's go and get started. This says ammonium phosphate is an important ingredient in many fertilizers. It can be made by reacting phosphoric acid with ammonia. So first thing we're going to need to do is write out a balanced chemical equation by saying that these are my reactants, right? It can be made by reacting these two things. This is going to be what's produced. So let's go ahead and do that. H3PO4. We're not given phase label information here, so we can just ignore it. Usually that's totally fine. Depending on the type of reaction that we're doing, it's going to be important sometimes and less important at other times. In this case, it's not that important. So here's our chemical reaction, but it's not necessarily balanced, right? The first step is writing out what our reactants and our products are, but then we need to make sure we go back and balance the chemical reaction. We always have to start with a balanced chemical reaction. So here I've just written down, these are my reactants, this is my product. So when I go through and balance, the things that I'm going to be looking for, I see that my phosphate, PO4, is intact, it stays as PO4. And I'm really going to balance that PO4 piece, separately. So I'm going to treat it as a PO4 piece and a PO4 piece. I've got one over here. I've got one over here. Typically, I would start with the hydrogen. Since I've got hydrogen showing up in multiple places, I would actually skip that. So I would go directly to this nitrogen. I would balance the nitrogen. So I see that I've got 3 nitrogens on this side. So this NH4 with a 3, that means I've got 3 of these pieces. So I'm going to put a 3 here. And then I would go and check my hydrogens. And typically it's gonna, if we just deal with these nitrogens and phosphates first, then the hydrogens will work themselves out. So I've got 3 hydrogens here, plus 9 hydrogens, would be 12 hydrogens total on this side. So 3 times 3 here is 9, plus these 3 is 12. And then 4 times 3, so I've got 3 of these NH4s, that would be 12 hydrogens. So this is now a balanced chemical reaction. So that's good. So the next step is really figuring out what the question's asking and sort of getting started. We're still organizing our information here, right? What mass of phosphoric acid is consumed by the reaction of 5.13 grams of ammonia? So when I'm sort of getting started and organizing my information and making a plan, I will typically write the given information right underneath whatever my reactant or product is, whatever is given. And then I'll also indicate what the question is. So grams of H3PO4 equals question mark, right? That's what we are ultimately looking for, to put in as our answer. What mass of phosphoric acid is consumed? That's what we're looking for. So I know that these coefficients here, this would be a 1 in front of here. If I don't have anything that indicates it's a 1, it's a 1 to 3 mole to mole ratio. That's how we're going to sort of figure out how much of this H3PO4 we're going to need to react with this NH3. We're going to use the mole to mole ratios. So I know that I'm going to need to convert this into moles of NH3. Once I have moles of NH3, I could convert that into moles of H3PO4. And then once I have the moles of H3PO4, I could ultimately convert that back into grams to get to my final answer. So this is going to be my strategy, right? My sort of flow chart to go through my problem. So let's go ahead and do that. 5.13 grams of NH3 times 1 mole, I'm converting grams into moles, 17.04 grams. So just adding up the molar mass for NH3, 17.04 grams, gives us 0.301 moles of NH3. So that's step 1. Maybe we'll label this 1, 2, and 3. This is step 1. So now I've got my moles of NH3, and now I'm going to use my mole to mole ratio. So this is sort of that stoichiometry idea. Every one of these phosphoric acids requires 3 NH3, 3 ammonia molecules to do this reaction. So, I can use that as a 1 to 3 ratio, mole to mole ratio, to convert from moles of NH3 into moles of H3PO4. That's going to look like this, 0.301 moles of NH3. We've got to be really careful with our units here, right? And showing our units nicely so it's easy to see, what's being canceled out. in that case, and I'll show it in this case too, 1 mole of H3PO4 over 3 moles using these mole to mole ratios. Here, this is a 1, we could put in a 1 here as well. Using that mole to mole ratio, 3 moles of NH3 is required for every 1 mole of H3PO4. My units of moles of NH3 will cancel out. 0.100, I think it's 003, showing that extra digit. We would round this to 3 sig figs, right? But we want to carry all those as we're doing our calculation. 0.1003 moles of H3PO4. And then in the last step, we're just going to convert from moles back to grams. Let's sort of move this up a little bit. So step 3, 0.1003 moles of H3PO4 times 98.0 grams. So just again, figure out what the molar mass is over 1 mole equals 9.83 grams of H3PO4. So that is our final answer. So let's run through sort of the strategy that we went through just one more time. So we started with our balanced chemical reaction. So we started with figuring out what our chemical reaction was. Then we had to balance it, right? Then we figured out what our number of moles of NH3 was. We figured out the mole to mole ratio to figure out the moles of H3PO4. And then we converted back into grams to get our final answer. So there's a lot going on in this problem. We've got to understand, how to write out a chemical reaction. We've got to understand how to balance chemical reaction. We've got to understand stoichiometry, mole to mole ratios. We've got to understand how to convert from grams into moles and moles back into grams. Yeah, so a lot going on. Definitely, if there's questions about any specific part, let me know, and I will try to clear that up for you. But this is a crucial topic for you to understand.